welcome back to AIUK in the lab stage. I hope you've had some time for lunch if you're in a time zone that has lunch around about this time. I've certainly gone off and filled myself up with a little bit of energy from food so that we can get through what looks to be a really action-packed and really interesting afternoon of content here on this stage, which is of course called In the Lab, as we said earlier on. The first session we're going to see now is even more real-life applications of AI. We've got two videos coming up for you, with a little bit of Q&A in between, so that we can get involved in finding out a bit more about what AI in action really looks like. So the first session, we're going to hear all about robotics at Edinburgh University, and Sethu, who's presenting, is going to come on after, and we're going to do a live Q&A. So again, please do tune into the Slido, pop your questions in there, and I'll make sure I'll put them to Sethu after we do have the video. We'd love to hear from you guys and make sure we're putting all of the best questions to our speakers today. So without further ado, let's roll the video from Edinburgh Robotics.
Welcome to the Base Centre, where great minds meet from academia, industry and the public sector to address some of the greatest challenges humanity is facing through the use of data science and AI. And I'm director of the Base Centre, the University of Edinburgh's 45 million data science and AI innovation hub. We're a community of around 500 people, engineers, mathematicians, computer scientists, professionals from startups, corporates, innovation partners, working together in the same place to drive impact from the use of data and artificial intelligence. The Base Centre came about in 2018 as part of the university's ambition to create an outward-facing space where we breathe the same air with partners from the economy and society at large, and embark on innovative projects to really leverage the power of data and AI for the benefit of society. We have a long-standing partnership with the Alan Turing Institute. The university is one of the 5 founding partners of the institute, and our roboticists, AI experts, mathematicians work closely with others across the UK on very interesting science and innovation projects. The centre has been open for just over 3 years now. We've been exceptionally successful. For example, we've managed to raise over £100 million worth of investment into the local tech ecosystem. We have brought around 40 million of R&D investment into the university around collaboration projects and innovation activities we do. And there's lots of other things we do. We provide upskilling programs for professionals in the workplace, helping them get the skills they need to step into roles in data and AI. We run incubation acceleration programs at the centre. For example, only last year we had around 77 startups come through our programs to get mentoring, business networking and investment raising skills. And we run the largest tech investor showcase conference outside London. In the UK, every year, where around 30-40 startups pitch to up to 200 investors from around the world. We build on the strength of the university that's been kind of the birthplace of European AI in the mid-1960s and has grown from strength to strength in artificial intelligence. Next to us is the School of Informatics, which is probably one of the top 5 largest clusters of computing research in Europe, where there's kind of several hundreds of researchers and PhD students working in AI, and we have great strengths in areas such as robotics, natural language processing, machine learning, but also in the application of AI in medicine, health and social care, financial services, engineering, and many other areas of application. We have great ambitions for AI. We know that AI already does great things, but we think it can do even greater things, and the next roadblock we need to overcome is to bring a lot of the different systems we have nowadays that can perform narrow, simple functions reliably, to put those together to really achieve the kind of levels of autonomous, intelligent action and decision making that we would want AI systems to perform for us. Of course, always with the human in mind, and always making sure that we do that sort of innovation and research in responsible and ethical ways. So one of the big challenges we're focusing on is around health and social care. We know our population is aging. We know that if we want to care for people effectively and in a cost-efficient ways, we're going to have to use technology to support them. And we have people across the university at the Base Centre, and in fact working also with the Turing, on different aspects of this, from building intelligent care homes to doing prosthetics, to having robots that can assist surgeons in the operating theatre, but also all the research around drug development, genomics, and of course the addressing problems such as the COVID pandemic, where we've played a key role by, for example, performing the first study that demonstrated the efficacy of vaccines. Another area is certainly climate and the environment. Here we want to look particularly at how we can work across different types of data. We focus at BASE a lot on Earth observation data, satellite data, and if you combine that with health data, census data and financial data, you can do very, very interesting things. For example, you can look at the financial impact of flood risks, and you can take remedial measures to avert these catastrophes and, for example, understand where you need to invest to prevent financial difficulties for the population, but then also the health risks that are associated with that. These are just two examples. There are many, many more.
Hi, my name is Sethu Vijayakumar. I'm a professor of robotics at the Edinburgh University. I'm also the co-program director of AI at the Alan Turing Institute. Some of the programs that I lead, especially in the space of robotics and autonomous systems within the AI program, focuses on how robotics can play a bigger role in some of the bigger social problems that we are going to face in the coming sort of next 10 to 15 years. So everything from aging society to dealing with our infrastructure, so repair and maintenance of assets, as well as working in hazardous environments. Robotics as a field has always looked at technology and how to create the best machines, robust machines. But within Turing, and this is of special relevance to AIUK audience, is that we are looking at how can we make some of those machines more robust, how can we make some of the actions of those robots explainable, verifiable. And the reason why we are trying to do that is because if you want robots to be accepted in society, then verifiability, trustworthiness, and essentially figuring out if when something goes wrong, can we ensure that it does not happen again, is of utmost importance. So safety, verifiability, explainability is really the core of the science that we are doing within Turing in the space of robotics and autonomous systems. In particular, there are two areas that I would like to pull out, which is maybe of relevance to the AIUK audience as well. So one is in the area of healthcare, and specifically, we are collecting tons of data with the new gadgets that we are using in surgical instrumentation or in sort of monitoring how patients move about with gait and exoskeletons. So the data is there. Now the real challenge is how do we take that data and create something useful out of it that can be used to improve the quality of life, do preventative maintenance on human bodies, but also do novel kinds of interventions. So for example, when COVID hit, one of the big challenges we had was how do we do in situ experiments in a human lung using, say, things like snake robots, and that's one of the domains that we've been focusing on. The other area, the big area, is how do we get people out of harm's way? So when people are doing preventative maintenance in, say, the rail network industry or under sort of mines or bridges that are in extreme environments, then humans alone, just the capacity doesn't exist. So we wait for a disaster to happen before we do anything about it. So robotics is going to be the solution to address those challenges. Now let me try and hand you over to Vlad and Ram to have a sneak peek inside the labs in the base building.
Welcome to the Field Robotics Lab at the University of Edinburgh. My name is Vladimir Ivan. I'm a senior researcher here in the Field Robotics Lab. Span of research that we do goes everywhere from robot arms and more sort of industrial applications all the way through mobile robots, legged robots, up to humanoids. One of the unique things about our lab is that we have this breadth of robots, breadth of different interests, and we have all the different hardware and software and expertise to attack really, really interesting complex problems. So one of the problems we're working on is looking into factories that are reconfigurable and building robotic systems that can adapt. You can move them around the factory, they can learn new tasks, you can deploy them, and you do not need a whole crew of roboticists to set up a new workplace. Another really exciting project that we're engaged with several partners across Europe is on assisted healthcare. It's where we want to deploy robots in hospitals to help alleviate some of the staff so that they can focus on tasks that they're trained for. And we can have robots going around the hospital, delivering tests and results, moving different items around, interacting with people, maybe delivering lunches to patients.
Hi, I'm Ram Ramamurthy. I'm a professor of robot learning and autonomy here in the School of Informatics in Edinburgh. I'm a Turing Fellow at the Alan Turing Institute, and I'm a member of the Edinburgh Centre for Robotics. We're here in the Assisted Living Lab, which is the home of my group, my postdocs and PhD students. And together we study problems of robot learning in order to make robots more capable and autonomous, aimed at a number of different applications, including in the health and social care domain. A current theme in our work is to try to understand human skill so that we can transfer it to make the autonomous robot more capable. So one example of human skill might be, what does a physician do when they're trying to use an ultrasound scanner to look beneath your skin to try to understand what's going on. It could be a deformity, it could be various features in your body. And if you are a really well-trained ultrasound technician or a physician trying to understand your body, they have a very detailed understanding not just of what is where, but also sort of what different organs should feel like, what should be in the view of the device as they move across it, and how they should kind of gently maneuver the instrument such that they get the best possible understanding of what's underneath. There are a number of different projects around the world in which people are looking at ways in which they can bring instruments, robots, and apply them in the medical context. The idea of using robot learning as the mechanism to achieve autonomy and to try to take that into these kinds of cutting-edge applications, it's only slowly emerging, and there are only a few places around the world where it's being done in this way. And I would say that in the UK context, and in particular what's going on here in the Bay Centre and in informatics, we are on the forefront of that kind of technology.
Hi Sethu, thank you so much for joining us here today, and thank you for pulling together or helping pull together this wonderful video that really gives us an insight into what's happening up at Edinburgh. I wonder if you could just start by telling us a little bit about some of the things that you're particularly thinking about in terms of challenges needing solved to take us to the next stage when it comes to producing these robotics.
Yeah, thank you, Gemma. It's actually a
Sorry,
big journey.
2 seconds, Sethu.
Yeah. Okay.
There we go. Off you go.
Okay. Yeah. Thank you, Gemma. I think it's an exciting time to be doing robotics because we can see already applications of robotics in domains ranging from healthcare to inspection and repair and maintenance. And some of the biggest challenges comes from the fact that it's easy enough to build some of these robots, complex robots with arms and legs. But the real challenge is about making them behave and act robustly. So very topical to AIUK, how do I actually put in the artificial intelligence into the brains of these robots? So some of the approaches that we've been taking include things like taking the data and experience from both human actors and previous experience of the robot and using machine learning algorithms to improve their behaviors and adapt.
And just to remind everybody who's watching here, I've got Slide open in front of me. So if you have any questions you'd like to ask Sethu yourself, please do submit them here and I will put them to him as soon as I can. Sethu, I'd love to kind of pick your brains a little bit on, I guess for a lot of people seeing robotics advance, and I'm talking more people who are not in the sort of AI development community who are perhaps are not as close to it. There's a lot of fear around robotics. There's a lot of kind of worry around what exactly is going on, how are they being built, how are they going to be utilised, and so on and so forth. So how does the Base Centre and your sort of team as a whole approach building these robotics in a way that's going to make, really achieve their potential whilst also not succumbing to some of those places where, people do have genuine fears?
Yeah, it's a great question. And I think this is part of designing, when we do research in robotics, part of designing the solutions involve not just the technology side of things, but looking at adoption, looking at the real needs of the people. And in some sense, rather than thinking about robotics as replacing or doing a particular job instead of you, it is better to think of robotics as a tool that will enable you to do some of these things much more efficiently, go and achieve some of the tasks that are inherently dangerous for humans, but also in some sense adding capabilities that does not exist. For example, there's lots of new avenues, for example, exploring in the depths of the oceans, looking at decommissioning old nuclear power plants that are inherently dangerous for humans, and also doing things like asset management. So, for example, if you've built a large block of flats or a big underground or a metro system, looking at monitoring the life of those systems to ensure that you get enough warning before something catastrophic happens, like a breakdown or some sort of accident. So in a way, it's about enhancing the ability of humans to do the things with technology rather than replacing some of the kind of skill sets. And actually, this is particularly important in healthcare, because the way robotics is being used in healthcare is by augmenting the capabilities of the specialists in the field while ensuring that the errors from human errors are taken out of the picture.
Yeah, absolutely. And I always think it's kind of interesting. In the last sort of year or two, there's been quite a few books, sort of history of technology books that have been published all around the sort of Luddite movement. And I think it's really usefully reframing what it actually meant to be a Luddite. It's not about saying, oh, I don't want technology. It was more about not wanting technology that was going to adversely affect humans. And I think sometimes when it comes to talking about robots and automation, we can kind of get caught up in these discussions around replacement of jobs and so on and so forth, which of course is something that people are absolutely understandably worried about, but it's actually how do we reframe the conversation in terms of, well, what does good technology look like that's going to help us as opposed to bad technology that's going to have adverse effects. It looks like we're getting some great questions in from the audience, so thank you, everybody. Let me put some of these questions to Sethu now. First question from Surabi. What do you think will be the level of advancement in robotics in terms of the variety of tasks that we can accomplish in the next 10 years?
It's quite hard to predict ahead, and it's like looking into a crystal ball. But I think we are already seeing significant deployment of robotic platforms in things like logistics and warehousing, where you're thinking about not just the sort of large companies stocking your online goods, but actually doing smart delivery, so door-to-door delivery of the last mile delivery so that the logistics can be optimized for various things, including sustainability. So in other words, you want to make sure you source local, you use the demand and sort of source things that can be then have the minimal sort of footprint in terms of carbon footprint. So that's one area that's definitely smart cities logistics is where we're already seeing a big kind of impact. And of course, just following on that theme, transport. At the moment, transporting goods, I mean, COVID has put a lot of these things into perspective. So we've seen a shortage of long haulage drivers, for example. So there are some things where autonomous driving, not in the sense of autonomous drivers, so autonomous driving taking over the role of regular, your commute, but actually long haul transport of goods as a convoy, for example, on highways. This is where autonomous driving can play a significant role in reducing accidents, in reducing the kind of congestion through some sort of automated planning aspects. And finally, I think the big area where a lot of us have got personal interests in is in the area of aging and assisted living, where we are getting the inverted pyramid, and invariably different sort of communities, especially in the Western world, but increasingly more so sort of outwith of the Western world, we are finding scenarios where care of the elderly, care of people who want to still live active lifestyles in their homes is becoming challenging. And I think technology and robotics and AI is going to become part of, is going to be one part of the big solution to be able to allow us to lead healthy lives in our homes.
Amazing. Yeah, so it's a difficult question to ask you to predict the next 10 years, but it's always interesting to hear people who are at the forefront to see what they're excited about and what they're looking forward to seeing what's going to come. Another question from the audience is from Katie Beckwith. Drug development was mentioned. In what ways are the Centre approaching this? Are you looking into lead design or prediction of molecular properties?
Yes, so this is in particular relevant for the AI and the machine learning side of things, and less so for the robotics. Of course, we've got something called Lab Forge, or use of robotics to do automated experiments, but that is a more traditional use of robot technology. But the really exciting aspects in drug discovery is about using things like predicting the efficacy of drugs in novel conditions, looking at almost doing so-called simulations of the effectiveness of drugs using models. So you can think about tweaking different aspects of the gene pool or some aspects of the drug, and almost using data from prior real-world trials to then generalize across novel drugs, novel molecules, novel sort of genome sets. And I think it is going to revolutionize the way we deal with new kinds of diseases, because it's going to potentially cut down significantly the cycle time between testing and deployment, and and we've already seen this happen with the vaccines already reacting to novel strains, and using that technology to not just for vaccines but for drug discovery, for dealing with some of the big diseases of our time like cancer, looking at a combination of robotics technology for delivery of radiotherapy in situ experiments in the human body, so that we are able to look at how we can effectively deliver drugs without affecting the surrounding organs or collateral damage, so to say.
Amazing. Let's go to the next question we've got here from the audience. What is your best practice approach for achieving robust behavior robotics in real-world applications?
Again, great question. I think as robot practitioners, one of the things we see very often is there is a gap between what we can demonstrate in the lab and how robustly we can transfer that technology into the real world, which is unstructured. We can't account for every possibility. There's noise, there is unpredictable behavior, there is system dynamics that involves multiple actors. So one of the things that we are looking at in terms of the technology to make that, we call it sim to real transfer, really robust, is by looking at both robotics and machine learning technology that is verifiable by design. So what I mean by that is, rather than building technologies and testing things and then thinking of robustness as an afterthought, if you can build in trustworthiness, verifiability, explainability of these systems by design, then we will end up with systems that are potentially inherently much more explainable when something goes wrong, or is perhaps or for example, if we want to probe into the workings, inner workings of some of these machine learning algorithms, it becomes much easier to ensure that something that has gone wrong before does not go wrong again, or we understand the causal reasoning behind it. And I think that is extremely crucial for new development of technology, so that we can gain the trustworthiness, or gain the trust of the end users, because without that, it's really no use.
Absolutely. This is an interesting question that's also come in from the audience. This one from Jason Ward. One theme that is reoccurring is the combination of varied data sources. Are there any insights and advances from robotics that could inform data fusion challenges? An interesting question.
So inherently in robotics, we do deal with data fusion. This is from day one of robotics. We've been so that's the only way we can actually work robustly. So let me explain a bit what I mean by that. So robots are equipped with various kinds of sensors, from cameras to LiDARs, which are sort of laser-based rangefinders, to kind of haptic sensors, which detect contact and forces, and torque sensors, and something called IMUs, or inertial magnetic units, that can sort of measure and report in real time the pose of the robot, often at 1,000 hertz or more. So you get about 1,000 readings per second. So it's only by combining these multiple sources, just like as we humans do, by combining our sense of touch and smell and eyesight. It's exactly the same strategy for robotics and robots to sense and perceive the world, because it's not enough to be able to just capture an image, because often there are aspects of an image that you will not understand. For example, force, you can only detect by contact or force torque sensors. An image will not tell you how hard you're pressing against a particular contact. So sensor fusion is by default something that we do. Now, doing it robustly is very, very hard to do. So this is lots of research going on in this area. But more excitingly, in the recent sort of past, I would say 5 to 10 years, we've seen miniaturization of some of these very advanced sensors, so that these days in one of my sort of cell phones, I can carry some sort of sensor that can do 3D scan of the environment and build a model of the environment and localize myself. This was something that was maybe even 10 years ago, something that used to be only done in the labs. So the form factor of these sensors are becoming really, really accessible.
Amazing. I think we've got time for one final question before we finish off this part of the session. This is quite a funny question, I think, from Jonathan Van Dyke. Does injury lawyers for you have a life expectancy? Will there come a point where humans no longer need to worry about the risk of harm at work?
Wow. Okay. It's an interesting question. So I cannot predict when injury lawyers are going to go out of business, but some of the research that we're doing are definitely looking at some of the aspects of ergonomics that are involved in human-robot interaction. So one of the things in assisted living we are working on is how do humans and robots collaborate to help a person sit to stand, dealing with them in terms of their helping them for the mobility. And ergonomics definitely plays a big factor. And I think if we are able to do that, effectively, then we will reduce injury much more significantly than what's happening now.
Amazing. Sethu, thank you so much for joining us, chatting all things robotic. And of course, as I said, thank you for helping compile that video as well. It's really great to get an insight into what's happening up in Edinburgh. I hope everybody at home also joins me in thanking Sethu for joining us today.